Right, guys, we are in 4.6, Fit a Line to Data, starting on page 264. Two vocabulary words of the day. The first vocabulary word of the day is scatter plot, and these are defined in your book. But scatter plot is a graph used to determine whether there is a relationship between paired data. We're going to find that not every set of data that we graph is going to turn into a perfect straight line. So this is an example of what we can do with data that doesn't appear to be a straight line. And line of fit is a line used to model the trend in the data showing a positive or negative correlation. So this is going to make more sense in a few minutes, but for right now, make sure you have these definitions down. Our goal today is to make scatter plots and write equations to model data. This is in your book. It's a key concept. It's important, and it shows three examples of scatter plots. Okay, the first one, if you look, most of the points tend to be increasing as x is increasing, y is increasing, and we said that is described as having a positive correlation. Again, look at the data. If you can draw a line of fit, a line where most of the points are half or above, half or below, a line that best represents that, if it has a positive slope, it would be positive correlation. Looking at the second example here, again, looks to be decreasing. So as you draw a line of fit, that line of fit your goal should be to try to have half the points above the line and half the points below. The line itself does not have to go through any existing points. You're making a line that best models that, and that might not include any of the points on the graph. And finally, over here, we have an example of a scatter plot that really doesn't have a correlation. It's said to have relatively no correlation. It is neither positive nor negative. In this instance, we can't draw a line of fit. There is no way to make one model that best represents that data. So if you look in your book, this goes along with example 1, and they have a graph that I've put here. They have their scatter plot, and it says using this scatter plot, predict a reasonable test score for 4.5 hours of studying and 4.5 hours of television watched. So this first one I have here is studying. So if you look over on our x-axis, I can pick up a pen here. We're going to go over on our x-axis. This is 4. This would be 5. So 4.5 would be somewhere in here. So if we wanted to, before we do that, take a ruler, try to make our line of best fit. Oops. Sorry, going to try again here. Try to make a line of best fit. That didn't work. Let's try this again. Sorry, guys. Technical difficulties. Let's delete these two things and try one more time here with my line. Again, trying to make my line where half the points are above and about half are below. So if this is my line, and I'm going to erase this 5 because I moved the picture around, make sure the 5 is on the line. 4.5 would be about right there on my line. And if we were to estimate, I'm assuming that would give us approximately a score of 72. Using this graph of hours television watched, again, let's try and make my line. Maybe I can do this one on the first. I want about half the points above and half the points below in my line. I'm going to go about right there. We're going to, again, here's my 0.5, so 4.5 would be here. Be up here, looks like it's a little higher, so we could go maybe 76 would be our score. So that's what you do. You make your line that best represents your data and interpret it just like you would any other graph. So key concept, the directions, the steps, 4 steps, make a scatter plot. Decide whether it can be modeled by a line. In other words, look at your data. Is it a positive correlation or a negative correlation? If so, continue on. If it has no correlation or relatively no correlation, you're done. You can't model it. Going back to step 3, we would draw a line that closely fits the data, half the points above, half below if possible, and then write an equation using 2 points on the line. They don't have to be 2 points that were part of the original data. They have to be 2 points on your line. So in this case, it says use the data in the table to write an equation that models y as a function of x. So the first thing we have to do is plot our points. X is 1, y is 1, 2, 3. X is 2, y is 5, 3, 4, 5. X is 3, 1, 2, 3. And we're going up to 8, 6, 7, 8. X is 4, 1, 2, 3. 1, 2, 3, 4. We're going up to 9. 5 takes us up to 11, which actually comes off my graph here. I didn't do a very good job of putting my x and y. So hold on, I'm going to add a different graph in. All right, guys, I'm back with a slightly different grid here. And now it doesn't want to show. So hold on, we're going to try again to plot our data. And what I did was do a different scale here. So x, still plotting this data up here, going to write an equation. X would be 1, y would be 3, would be about there. X is 2, 5, 3 is up here at 8, 4 is at 9, 5, which would be halfway here between 4 and 6, would be up here at 11. And 6 is up here at 12. And 8 would be up here at 14. So here are my data points. I need to determine if there's a correlation, and I would say in this instance there is a correlation. There's a correlation that appears to be positive. So since it appears to be positive, we should be able to draw a line that best fits this, or line of fit. So I'm going to try and work here with my line. And again, the goal is to try and get, and that didn't work. Again, technical issues here. To try and get this line half the points above, half below. So I'm going to start again here and see. That's not what I want to do. Drawing a line. Sometimes technology just doesn't want to cooperate. I want half my points above and half below. Still having issues with my pen. Some days it is just not meant to be. Here we go. Trying again. I'm going to grab down here and try and get my whole line in. Half above, half below. Maybe I can work with that line as it appears there. Don't love it, but I think it might work here. So in this case, once I have my line, I need to pick 2 points that are on that line. 2 points on the line where I can come up with my slope and y-intercept. So I like to look for easy to read points, and I see one right there. So I'm adding that one in. Notice it's at an easy intersection, easy to read. And I'm actually going to use this point right here. So looking at this, I can identify my y-intercept as 3. So I know I have a plus 3 over here. Now I've got to look at my slope. I'm going from 0 over to 2. So over 2 steps. Remember, over's on the bottom, run's on the bottom. And I'm going up from 3 to 6. So that change would be 3. It is a positive slope, so my slope would be 3 over 2x plus 3. All right, guys, sorry for all the technical difficulties, but hopefully this makes it easier for you to understand as you review this at home.